The Suretest Analyzer is a specialized electrical testing device used to measure various electrical parameters, including voltage drops. Voltage drops occur when there is resistance or impedance in an electrical circuit, causing the voltage to decrease as it travels through the circuit. Voltage drops can affect the performance of electrical devices and indicate potential safety hazards. The Suretest Analyzer measures voltage drops by comparing the voltage at 2 points on the circuit, typically the outlet and the electrical panel. High voltage drops indicate excessive resistance or impedance in the circuit. Interpreting voltage drop results is crucial for identifying potential issues. A voltage drop greater than 5% may indicate a potential problem that requires further investigation. A voltage drop greater than 10% is usually considered a significant problem that requires correction. A voltage drop greater than 15% can be a safety hazard and should be fixed immediately. Several factors can affect voltage drops. Firstly, circuit length affects voltage drops. Longer circuits have higher resistance, leading to higher voltage drops. Secondly, wire gauge can affect voltage drops. Thinner wire gauges have higher resistance and more voltage drops. Thirdly, circuit load affects voltage drops. Heavily loaded circuits with multiple devices plugged in can draw more current, increasing voltage drops. Fourthly, loose connections can affect voltage drops. Poor electrical connections can create resistance and voltage drops. When using the Suretest Analyzer during home inspections, remember that while home inspectors are not typically qualified to diagnose and repair electrical issues, the analyzer can provide valuable insights into the condition of the electrical system. It can help identify potential safety hazards, as detecting high voltage drops can alert inspectors to potential wiring problems that may pose a fire or shock risk. Voltage drop measurements can supplement visual inspections of electrical components and document potential issues for further evaluation by a licensed electrician. By providing information on voltage drops, inspectors can help buyers and sellers make informed decisions about the electrical safety of the property. Always follow the manufacturer's instructions when using the Suretest Analyzer. Do not attempt to repair electrical problems yourself. Always consult with a qualified electrician. While voltage drops can indicate potential issues, they should not be considered a definitive diagnosis. Further investigation and testing by an electrician may be necessary. To elaborate further on voltage drop, it's essential to understand its implications and how to effectively troubleshoot issues. Voltage drop is the reduction in voltage that occurs in an electrical circuit due to impedance. Impedance encompasses both resistance and reactance, and it hinders the flow of current, causing a decrease in voltage along the circuit. Excessive voltage drop can lead to various problems, including reduced performance of electrical equipment, overheating of conductors, and even potential safety hazards. Understanding the acceptable limits for voltage drop is crucial. The National Electrical Code (NEC) recommends that voltage drop should not exceed 3% in branch circuits or 5% in feeders, resulting in a total voltage drop of no more than 5% to the farthest point of utilization. These limits are set to ensure that electrical equipment operates efficiently and safely. When using the Suretest Analyzer, it's essential to follow a systematic approach to accurately measure voltage drop. Firstly, ensure that the circuit is properly loaded. Connect a representative load to the circuit to simulate real-world operating conditions. This will provide a more accurate measurement of voltage drop. Secondly, measure the voltage at the source. Use the Suretest Analyzer to measure the voltage at the beginning of the circuit, typically at the electrical panel. This will serve as the reference voltage for calculating voltage drop. Thirdly, measure the voltage at the load. Use the Suretest Analyzer to measure the voltage at the point where the load is connected. This will provide the voltage at the end of the circuit. Fourthly, calculate the voltage drop. Subtract the voltage at the load from the voltage at the source to determine the voltage drop. Express the voltage drop as a percentage of the source voltage. If the calculated voltage drop exceeds the recommended limits, it's essential to investigate the cause of the problem. Several factors can contribute to excessive voltage drop, including undersized conductors, long circuit lengths, loose connections, and overloaded circuits. Firstly, undersized conductors can cause voltage drop. If the conductors are too small for the amount of current they are carrying, they will have excessive resistance, leading to voltage drop. Secondly, long circuit lengths can cause voltage drop. The longer the circuit, the greater the resistance, and the more voltage drop will occur. Thirdly, loose connections can cause voltage drop. Loose or corroded connections can create resistance in the circuit, leading to voltage drop. Fourthly, overloaded circuits can cause voltage drop. If the circuit is carrying more current than it is designed to handle, it will experience excessive voltage drop. To mitigate voltage drop, consider the following strategies. Firstly, use appropriately sized conductors. Ensure that the conductors are large enough to handle the amount of current they will be carrying. Consult the NEC tables to determine the appropriate conductor size for the circuit. Secondly, shorten circuit lengths. Whenever possible, shorten the length of the circuit to reduce resistance and voltage drop. Thirdly, tighten connections. Ensure that all connections are tight and free of corrosion. Use appropriate tools and techniques to make secure connections. Fourthly, balance the load. Distribute the load evenly across multiple circuits to prevent overloading any one circuit. In addition to the above strategies, consider using voltage drop calculators to help determine the appropriate conductor size and circuit configuration. These calculators take into account factors such as circuit length, load current, and conductor material to provide accurate voltage drop estimates. Regular maintenance and inspection of electrical systems can also help prevent voltage drop problems. Inspect connections, conductors, and equipment for signs of wear, corrosion, or damage. Address any issues promptly to prevent them from escalating into more serious problems. When using the Suretest Analyzer, it's essential to understand its limitations. While the analyzer can provide valuable information about voltage drop, it cannot diagnose the underlying cause of the problem. Further investigation and testing by a qualified electrician may be necessary to identify the root cause and implement appropriate solutions. Also, be aware of potential sources of error when using the Suretest Analyzer. Ensure that the analyzer is properly calibrated and that the test leads are in good condition. Avoid making measurements near sources of electromagnetic interference, as this can affect the accuracy of the readings. When reporting voltage drop measurements, be sure to provide all relevant information, including the source voltage, load voltage, voltage drop, and circuit conditions. This will help others understand the context of the measurements and make informed decisions about the electrical system. In summary, voltage drop is an important consideration in electrical systems. By understanding the causes of voltage drop, the acceptable limits, and the strategies for mitigating it, you can ensure that electrical equipment operates efficiently and safely. The Suretest Analyzer is a valuable tool for measuring voltage drop, but it's essential to use it properly and to interpret the results in the context of the overall electrical system. Remember to always consult with a qualified electrician for any electrical work or repairs. This will ensure that the work is done safely and in accordance with applicable codes and standards. It's also important to stay up to date on the latest electrical codes and standards. The NEC is updated every 3 years, and it's essential to be familiar with the latest requirements. This will help you ensure that your electrical work is safe and compliant. Finally, remember that electrical safety is everyone's responsibility. By taking the time to learn about electrical hazards and how to prevent them, you can help protect yourself and others from electrical shock and fire. Using appropriately sized conductors is paramount in preventing excessive voltage drop. The National Electrical Code, specifically Table 310.15b16, provides ampacity ratings for various conductor sizes based on their insulation type and ambient temperature. Selecting a conductor with an ampacity rating that meets or exceeds the calculated load current is crucial for minimizing voltage drop. For example, if a circuit is expected to carry 20 amps, a 12 American wire gauge AUG copper conductor with THHN insulation, which has an ampacity of 25 amps at 30 degrees Celsius, may be suitable. However, for longer circuit runs, a larger conductor size, such as 10 AWG, may be necessary to limit voltage drop. Circuit length significantly impacts voltage drop. As the length of a circuit increases, so does its resistance, leading to a greater voltage drop. The relationship between voltage drop, current, resistance, and length can be expressed using the formula voltage drop equals 2 times the length in feet times the current in amps times the resistance per foot divided by 1000. This formula highlights the importance of minimizing circuit length whenever possible to reduce voltage drop. In situations where long circuit runs are unavoidable, consider using a higher voltage system. For instance, a 240-volt circuit will experience less voltage drop than a 120-volt circuit for the same load current and conductor size. Proper termination and connection techniques are essential for minimizing resistance and voltage drop at connection points. Ensure that all connections are clean, tight, and properly torqued according to manufacturer's specifications. Use appropriate connectors and termination methods for the conductor type and size. Avoid using similar metals, such as aluminum and copper, in direct contact, as this can lead to corrosion and increased resistance. Regular inspections and maintenance of electrical connections are crucial for identifying and addressing potential issues before they escalate. Overloaded circuits are a common cause of excessive voltage drop. When a circuit is overloaded, the current draw exceeds the ampacity of the conductors, leading to increased resistance and voltage drop. Avoid overloading circuits by ensuring that the total load connected to a circuit does not exceed its rated capacity. Use appropriate overcurrent protection devices, such as circuit breakers or fuses, to protect circuits from overload conditions. Regularly monitor circuit loads and identify any circuits that are consistently operating near their maximum capacity. Consider redistributing loads or adding new circuits to alleviate overloading. In addition to the factors mentioned above, other considerations can impact voltage drop. Ambient temperature affects conductor resistance. As temperature increases, conductor resistance also increases, leading to greater voltage drop. Directing factors for conductor ampacity are provided in the NEC to account for high ambient temperatures. The type of load connected to a circuit can also influence voltage drop. Inductive loads, such as motors and transformers, can cause voltage drop due to their lagging power factor. Capacitive loads, on the other hand, can help to improve voltage regulation. Power factor correction techniques can be used to minimize voltage drop caused by inductive loads. Harmonic currents, which are non-sinusoidal currents that can be generated by electronic devices, can also contribute to voltage drop. Harmonic filters can be used to mitigate harmonic currents and reduce their impact on voltage drop. When evaluating voltage drop, it's important to consider the specific requirements of the equipment being powered. Some equipment is more sensitive to voltage fluctuations than others. Consult the manufacturer's specifications to determine the acceptable voltage range for the equipment. If the voltage drop exceeds the equipment's tolerance, it may be necessary to take corrective actions to improve voltage regulation. The use of voltage regulators or constant voltage transformers can help to stabilize voltage and minimize the impact of voltage drop on sensitive equipment. These devices automatically adjust the output voltage to maintain a constant level, regardless of variations in the input voltage. In some cases, it may be necessary to install dedicated circuits for sensitive equipment to ensure that they receive a stable and reliable power supply. Dedicated circuits minimize the impact of voltage drop caused by other loads on the same circuit. Consider using separate circuits for lighting, receptacles, and dedicated equipment to isolate them from each other. When planning a new electrical installation or renovation, it's important to perform a voltage drop calculation to ensure that the conductors are properly sized and the circuit configurations are optimized for minimizing voltage drop. Use voltage drop calculators or consult with a qualified electrical engineer to perform these calculations. The results of the voltage drop calculation should be documented and used to guide the selection of conductors, overcurrent protection devices, and other electrical components. Regular monitoring of voltage drop can help to identify potential problems before they become critical. Use a voltmeter or a power quality analyzer to measure voltage drop at various points in the electrical system. Compare the measured voltage drop values to the calculated values to verify that the system is operating within acceptable limits. Keep a log of voltage drop measurements and track any trends over time. Significant changes in voltage drop may indicate a developing problem that requires investigation. When troubleshooting voltage drop problems, start by checking the most common causes, such as loose connections, overloaded circuits, and undersized conductors. Use a systematic approach to isolate the problem and identify the root cause. Consult with a qualified electrician if you are unable to resolve the problem yourself. Remember that electrical work can be dangerous, and it's important to take all necessary safety precautions. Always de-energize circuits before working on them and use appropriate personal protective equipment such as insulated gloves and safety glasses. Follow all applicable electrical codes and standards to ensure that the work is performed safely and correctly. By following these guidelines, you can minimize voltage drop and ensure that your electrical system operates efficiently and safely.